You may reshare your screen. Sometimes it works. Yeah.
Okay, I think you are able to see the second screen, right?
Yes.
Okay, I'll continue then. Sorry for the disruption. The Indian economy, just I have a couple of slides before I get on with the topic on the current scenario in India. So Indian economy clocked a healthy growth rate of 8.4% in the second quarter of the financial year 2021-22. Talking about specifically about the construction industry, it has registered an annual growth of almost 15.9% in real terms. That is on a low base of 12.3% negative decline in the year 2020 because of COVID. But in the coming years, 2022 to 25, it is expected to grow at an annual growth of rate of 6.4%. Along with the huge investment that the government is making in the infrastructure, the government policy to increase private participation is also helping. And there is a lot of private participation coming in terms of ports, airports, power sector, and things like that, which is also very exciting as far as the civil engineer is concerned. And there is a lot of foreign direct investment which is coming into India. Just to give you a feel for it, almost $50 billion between April 2000 and June 2021. Now, along with the very exciting times that we are all living in as far as the civil engineering fraternity is concerned, there are certain challenges. Let's look at that quickly. If we talk about the financial challenges, then the cost of capital is very high. And both in terms of the project cost, also the capital cost on the plant and equipment that one needs to purchase to execute these projects. So we are that kind of industry which is capital intensive. And there are delayed returns on investment. Typically, the gestation period is very large on infrastructural projects. Long-term payback period. Access to financing is very limited. Not everybody is able to get the financing done, especially the smaller contractors. Low capacity of private players. Adverse cash flows on projects. Many times we see that because of that, the contractor or the project faces challenges. So these are some of the typical financial challenges that one has to face working in India. As far as the execution of projects is concerned, I believe that technology adoption can be done to expedite things, to improve the situation, but we are currently very slow at it. So this is a challenge that we all have to face and try and improve. Need for multiple clearances. A project when it starts, there is a need for multiple clearances requirement, from many different departments, and that takes time. The practice of reverse auction, which has been introduced of late, it started with PSUs and gradually it has come to even the private sector, is not a good practice. We are talking about a very scientific way of executing projects, and this definitely does not qualify as a scientific system. Political and regulatory risks are there. I mean, just to give you an instance, NCR region, because of the pollution, construction sites are the first ones that get the attention of everybody, and the work is asked to be stopped. Land acquisition is a challenge. We also face shortage of skilled labor force. We need to have a system in India where skilled labor force gets generated and gets absorbed in the industry. Unusual rise in material costs. Recently, cement and steel, everybody is facing that situation. And of course, the COVID-19, it is still here. It has not gone away. So we are still facing that issue. Talking about challenges, there are also plenty of opportunities. Construction sector is critical for revival of the economy, and this the government understands. And as it employs almost 49 million people, so I'm sure that the government focus is going to stay on this. A lot of people, almost 12% of the nation's working population is employed by this sector. India is expected to become the third largest construction market globally in 2022. Construction in all sectors contributes to about 60% of the total investment that takes place in India. And we all know about the National Infrastructure Pipeline, which they had announced some time back, 6,500 infra projects totaling about 105 trillion rupees, which subsequently was enhanced to 7,400 projects. Now, why new technologies? Since I'm going to talk about some of the emerging trends and new technologies, then why are we talking about it? Why it is relevant is because of these reasons. The project sizes have increased. Very large capital intensive infrastructure projects demand efficiency in terms of time and cost. There's a lot of money at stake, and time and cost are very important to make it viable. Accelerated construction periods are demanded. We can't be selective now. Earlier, we used to select our sites based on the geology which is suitable, but now we don't have that choice. So most challenging, geologically demanding sites, also we have to do the construction and we have to find a solution. Overlapping of design and construction phases requires that flexibility. Many times the design is still going on while the construction has started, and that requires flexibility in terms of construction methodologies. Design optimization is done very efficiently. Very efficient designs are being used, which means there's less margin of error. Hence, whatever technology the contractor is using in the field, that has to be just right every single time, first time and every single time. There's no margin of error. Deep excavations in the heart of mega city, as we are building the metros and underground metros, we are all facing this situation, 25-meter plus excavations right in the heart of the city through the center of the road. And we have to find the right solution to do that. Oftentimes, adopting new technologies, better solution to overcome these challenges. And they also, I believe, strongly believe that in terms of quality, durability, safety, and cost, they are better option many a times, and therefore we should be open to adopt them. Benefit in terms of saving of construction time would facilitate completing more projects for the country. Now, some of the recent technologies that I have personally used, I would just like to allow me to start from the right side, which is the compaction grouting. Now, traditionally, we have been doing permeation grouting in India, but this is compaction grouting, where a very thick mix of sands, cement, and admixture is made, almost 40, 45, 50 slump, and it is pumped into the ground at a very high pressure of almost 40 bars, 45 bars, so very high pressures. And essentially, you are relying on this grout to push the soil out, densify it, compact it, and it does not have to necessarily travel through the soil. So it's a little different technique. We utilized it for a site where we had to pass a TBM and a particular zone was rather soft. And so we had to densify it. It was loose rather. And we had to densify it. And we were able to do it and pass the TBM thereafter. So it's a technique, it's not common in India, hardly used. So this is one technique we can look at. Even for, I think, preventing liquefaction in certain areas, it will be very effective. Continuous flight auger piles, one trial we had conducted, it was a collective effort by the industry under the auspices of the Foundation Institute. And we were involved in taking the trial. Continuous flight auger is a very good solution, especially for industrial projects. because of it is a less diameter, and it's very quick. One pile we could do in about 35-40 minutes. So it's probably a very good solution in a number of cases, number of projects. Barrett piles are essentially rectangular piles constructed using the technique of diaphragm wall. And we have done this project where 46-story towers were rested on Barrett piles. They also, if they are in the boundary, then they can also be used as for shoring purposes. So they serve double purpose. And since the area is larger, the very large loads can be supported on Barrett piles rather than the circular piles that we are all familiar with. Now, as far as this presentation, I'll confine myself to two other technologies. One is a rock-socketed secant pile, not only secant pile, but is rock-socketed, and the spun concrete piles, these two technologies that I'm going to talk about in this presentation. So secant piles is basically a continuous strip of overlapping piles, which are used to form a retaining wall. As you can see in the picture here, we start with the pile number 1 and probably 5, 9, and then 13. In the next pass, we come and do the in-between piles 3, 7, and 11. And then we come in the third pass, and now we are actually cutting into the piles which were constructed earlier. These earlier constructed piles are called soft piles or the primary piles. They are constructed with low strength concrete and no reinforcement. And you are able to have an overlap. So that is the way third pass you can do 2, 6, and 11. And then come back, and the in-between piles left over also piles get completed, and you get a complete wall. The piles which are cutting into the soft piles are called hard piles, and they have the reinforcement cage, and hard piles are used to support the take the lateral pressure, earth pressure, and water pressure. Now, as far as the advantages, rock-socketed secant piles, I would just like to mention here that they can be compared with diaphragm walls. Diaphragm walls were typically used in the past in metro projects. Secant piles can be successfully installed in most difficult ground conditions, just like we have board piles. Certain advantages in board piles because you can get the different type of tools, you can adjust the diameter, you can go with very large diameter, you can adjust the way, you can do bunching of reinforcements. So all that flexibility what we have in board cast in situ pile also is available for rock-socketed secant piles done using the same technology as board cast. These are board cast in situ piles I'm talking about here. This method is ideal for urban construction. Why I'm saying ideal? Because of many reasons. Number one is that many times, most of the time, the area where we are working is very congested, thick traffic, very heavy traffic. And when you do diaphragm wall, you typically, and you have to socket in the rock, you require very heavy equipment. And it requires a larger space also. The quantity of slurry that will be required, almost 13-meter width is required to accommodate the rig, and cage making requires space. So you require a lot of space, which may not be available when you're working in urban setting. And that was the reason why the case history I'm going to talk about, we chose to go for secant piles. Secant piles can also be used to support vertical loads in addition to the lateral earth pressures. Now, one thing we have to remember is secant piles do require some special tools if you have to cut into rock, which was the case here. In case of diaphragm wall, of course, that equipment is called trench cutter. Requires a large investment. Almost one unit will cost us about 50 crores. But in case of piles, this may come down to about 7-8 crores for each unit. So there's a substantial difference in terms of price. And the flexibility that secant piles provide, you can also form a circular shape or change a 90-degree bend also you can tackle very easily. So it's much easier to get different shapes using secant piles as compared to a diaphragm wall. Now, it does have some limitations also, which I would like to mention here. Secant pile produces more hard joints. And once you have hard joints, there is always a possibility that that could be a weak joint and that could start leaking. And for a better control, we need to have very good workmanship here. That I must emphasize. Diaphragm wall has less number of hard joints, and therefore the potential for leakage seepage is also relatively less. Secant piles requires heavier reinforcement as compared to diaphragm wall, just because of its shape, circular and versus rectangular. So you can space out the reinforcement much better in a diaphragm wall, in case of diaphragm wall. So it's a more efficient cross section. Secant piles require special tools which have to be developed and used. Now, secant piles rock socketed, but if the rock strength increases and it is very hard rock, then it has got a limitation because you will not be able to cut through the very hard rock. Essentially, you're relying on a core barrel only, and therefore there's a limitation of the strength of rock, what you can penetrate. Sequence of piling becomes important. Therefore, the timing is very important in secant pile. You don't want the soft piles to keep on gaining strength, and then when you have to cut it, it becomes very hard. Although you're using a low strength concrete, but still it will gain strength with time. Therefore, the planning has to be very good. In secant piles, we do need a veiler beam, unlike in diaphragm wall. You can get away with that. And overlap in piles, rock socketed piles, the rock portion does have the reduced overlap, which I will explain a bit later. So the project that I'm going to talk about, case study 1, this happens to be Mumbai Metro Rail Corporation Limited project. And they have a line 3 in the city of Mumbai, which runs from Colaba to Seeps, almost 33 kilometers of it, divided into 7 packages. And we were working on one of the packages, UGC 4, which involves 3 stations, Siddhivinayak, Dadar and Shitla Devi stations, and about 10 kilometers of tunneling. Now, initially, as our experience was also, and as it is true for almost all contractors in the country, diaphragm wall experience is available. And we were also thinking of using diaphragm wall. But when we did the survey of the site and we found that the space was very limited and the traffic was very heavy, and VIP areas, some of the buildings were very old, almost 100 years old, 70 to 100 years old, we decided to go for secant piles. Now imagine we were not allowed to work in both the shifts. We were allowed to work only in extended shifts. And if you have to do a diaphragm wall panel, typical volume of concrete could be 100 to 125 cubic meters. And if that is not done in continuity, you will have to postpone it naturally to the next day. And that continuity has to be ensured, which was also a challenge that anybody can face if you're working in single shifts. So we decided to go with secant piles. The space requirement was much reduced. So this is the layout. I'm going to talk about Siddhivinayak station, just one of the stations. This is the layout. You can see 320 meters by 120 meters. This is the size, and it has got entry-exit points on different sides. The typicality of this location was that we were right next to the Siddhivinayak temple, which is a very old and reputed, respected temple structure. And we had to take care, whatever we do, we should not cause any damage, any harm to the neighboring structures of the temple, as well as there were 2 roads adjacent to it. And there were some tall structures resting on piles. Some buildings were also on open footing, so we had to ensure that water flow into the excavation was almost next to zero. We didn't want to disturb the old structures in the nearby areas. As far as the site stratigraphy is concerned, overburden soils from 0 to 10.5 meters. Upper strata up to 4.5 meter was just heterogeneous fill. But after that, we had gravelly clay extending to about 10.5 meters. And then groundwater table was at 2 meters. So very shallow groundwater table conditions. So we had to make sure that water flow into the excavation chances were bare minimum. That means the secant piles was to be done with very good workmanship and quality. Thereafter, we had rock 10.5 to the borehole termination depth of 35.5 meters. Primarily breccia, volcanic breccia, and there were basalts and tuff also present. You can see in the table shown here is the rock was starting at grade of 4, gradually 3, and then it was getting better with depth. And in this context, I would like to tell you that the secant piles we decided to terminate at a depth of 18.5 meters. Of course, this was to be checked in the field, what samples we were getting and all that. And we finally terminated these piles at 18.5 meters. And at about 16 meters.
Excuse me, Mr. Kumar.
Sorry?
Excuse me. Actually, yeah, time is up actually. So I will appreciate if you can complete within.
I'll certainly try to complete.
Yeah. Sorry to interrupt you. Yeah. Thank you.
No issue, sir. So at 16 meters, we provided a ledge of about 1 meter, and thereafter we took a vertical cut, near vertical cut, actually 85 degrees. And that is how vertical cut was found to be stable in this type of rock. And it was just shotcreted and rock bolting was adopted. And this is the system that we followed. This is the guide wall which we used. Guide wall must be, I must emphasize that guide wall should be used when you're using secant piles, because the verticality becomes very important. There were 765 piles, soft, and 765 hard piles. The center to center spacing was 880. The diameter of the pile is 800. 175 millimeter was the overlap between the soft and the hard pile. I mentioned here the grades of concrete: guide wall M25, soft pile M10, hard pile was M40. And that is how the whole secant pile wall was constructed. Since we are running short of time, I'm only going to mention some of the important points. I've already, the cycle time, which was very important. Soft pile, approximately 12 hours it took us to complete one pile. Hard pile, almost 16 hours. And this was important because we were working in extended shifts. So we wanted to make sure that we get one pile in one shift. We don't have to continue it the next day. So that became possible. But this was possible with the development of the refining of the tool that we developed. I'll show you the pictures of that. This is the completed structure. You can see the depth of excavation is 26.5, 27 meters now. And you can see the anchor layers, different layers. And this places where the opposite walls were not far away, we used struts, entry exit points. These were some of the tools that we developed in India. We wanted to make sure that this technology, if it has to continue, we don't have to import anything. And these we worked with the local people here, and we developed them here. Casing adapter and casing joint and casing shoe. These are some of the teeth. These are used, of course, in the rock portion where the core barrel is there, just like you do any other penetration into rock with core barrel. There's nothing special, but this is the one which we had at the bottom of the double-walled casing, which we developed. And this was actually cutting into the soft pile and also in the soil portion. So the casing was doing all the cutting till the top of rock, and when we entered the rock, we used a core barrel. Since noise was also an important issue, we used this hydraulic arm. We developed this, and we were able to. It just touches this. It can be moved out and in. Once it comes inside, the soil can be cleaned very easily without any noise. Now I'll just, I have very few slides, sir. Let me also cover this spun concrete piles, which is a different technology altogether. These are precast piles. These are hollow piles. And typically the diameter is up to 800 millimeters. These piles are constructed or fabricated in factory settings. So the quality of the pile is excellent. They can be transported. It is typically cast in 12-meter lengths. That is from transportation point of view. And once it goes to the site in pieces, they can be driven into the ground. So this is a driven type of pile. Manufacturing process is cage preparation. Typically 7-millimeter wire HT wires are used. There is almost a 50% saving in terms of material, both in terms of concrete and steel. If I compare this with the board cast in situ pile. So in today's scenario, I think it's a very important saving. Here some pictures from the factory settings, and this is pre-stressing is going on. Once you put the concrete in it, it is rotated at a very high RPM of 1500 to 1600 RPM, which densifies the concrete, and you get very high grade of concrete of about M50, M60, M70, M80, like that. Spinning is going on here. Then steam curing for about 8 hours and gains sufficient strength that you can carry it out, and water curing if required. So that is how the piles are made. I've already told you the saving of almost 55% in terms of material saving. Much higher density, durability is ensured, and highly corrosion resistant. So it's a very clean operation in the field. But we should also be aware that transportation costs at times can be very high while it is being fabricated in India, made in India also, but there are very few places where it is made. So transportation can be high. Wastages are more if in variable ground conditions, because the parts sticking out of the ground, one has to break and it has to be wasted. Not conducive for bouldery and rocky strata. And pile capacity is limited to the limitation of the diameter. And in India, at least, it is 800. Of course, overseas, it is much larger. Diameters are getting used. So this is the case study. Filled up soil 0.5. Then we have silty clay extending all the way down to 27.5, followed by sand. Our piles were designed to go 22 to 24 meters only in this type of soil. 1684 number of 600 millimeter diameter piles, spun concrete piles. And we used a 9-ton hydraulic hammer. Hydraulic hammer is much better in terms of ensuring that the piles don't crack. This is a better option than diesel or pneumatic hammers. And we had 600 millimeter diameter piles. On an average installation time for each pile was about 3 hours only. So here you can see the advantage that you have. And with 5 number of rigs, we were able to drive 25 to 30 number of piles. The set criteria that was used was 55 millimeter for 10 blows. And average blows recorded was about 37 blows per meter. In the field, you can weld 2 pieces just like this. It has got end plates, steel plates. So those can be welded, and the pile can be continued longer than 1 piece, which is what we did. We reduced the second piece to 10 meters because we found that they were sticking out of the ground. So 24 meter was a little high, and we reduced it to 22. And the compression load tests that we did showed the test load was 252 tons for the 600 millimeter diameter pile. And it showed 6.6 and 8 millimeter as the maximum deflection settlement. The project was completed 7 months, which was 1 month ahead of schedule. And the reason spun concrete piles were chosen was because they had an advantage in terms of time as compared to the board cast in situ piling. So you can see that this can also be done very quickly. In concluding remarks, what I would like to say here is that very large capital intensive projects are being taken up in significant numbers in the country today. This means that the cost and time are very important factors. They're more relevant and important than ever before. Rapid growth in underground construction is also posing new challenges. The projects are now being built with accelerated construction periods. in densely urbanized areas and having complex geological formations. Therefore, we must explore different possibilities, different technologies, and use the best one that is available to us. These challenges demand newer construction methods and selection of the right one. I think there should be no doubt that these techniques can be successfully executed or adopted, the two techniques that I have talked about in this presentation in India, as well as if ground conditions are conducive for that technology. The case study is expected to provide confidence to the industry for the adoption of these new technologies in the future. With this remark, I thank the organizers for giving me this opportunity. And I would also like to thank my colleague, Mr. Ram Deshpande, who helped me prepare this presentation and write the paper. Thank you all.